So this video is going to teach you how to find the equation of a quadratic function from a graph. And if you have a graph like this, where you're given the quadratic and you're given the vertex of it, and you're given one other point, here's how you can find it. So I wrote this format for the quadratic equation, which is the vertex formula. And what h is the x value of the vertex, and k is the y value of the vertex, and a is like how much you're multiplying this whole thing by, like the dilation of the graph. So we already see that the vertex is 3, -1, so we can just plug these values in for h and for k. So we get y equals a times x minus 3 squared plus or minus 1 because k is -1. But we still don't know what a is. So in order to find a, we use the other point, which is 2, 1. So we just plug in 2 for x and then 1 for y. So we get 1 is equal to a times 2 minus 3 squared minus 1. And then 2 is equal to a -1 squared. And 2 is equal to 1a. So a equals 2. And we just plug this back into the original format. So y is equal to 2x minus 3 squared minus 1. And this is your equation for the graph. But once we get this, we're still not done. We should still convert it into standard form. So the first step to do that is just to factor out this x minus 3 squared to get y equals 2 times x squared minus 6x plus 9 minus 1. And we get y equals 2x squared minus 12x plus 18 minus 1. And 18 minus 1 is just 17. And we have this as our final answer. So even though we have this as a complete answer, we should still always convert it to standard formula unless you're told otherwise. So what if we have a graph where we're given both of the zeros and one other point? Well, we don't have the vertex, so we can't use the vertex form to find it, but we do know both of the zeros, and so we kind of know what it's going to look like in factored form. So since the zeros are -2 and 3, it's going to be something like this. Y equals a times x plus 2, because if one of the zeros is -2, then if you plug in -2 into x, it's going to be 0, and multiplied by x minus 3, it's all going to be 0. So if you plug 3 in, this is going to be 0. If you plug -2 in, this is always going to be 0. So we know it's going to look something like this. But we don't know a. So we just use the third point to find a. Again, we plug in 4 for x and 18 for y. So 18 is equal to a times 4 plus 2 times 1 minus 3, which is 18 equals a times 6 times 1. And this is equal to 6a 18. So that means a equals 3. So now we plug in a into the original form, and we get y equals 3 times x plus 2 times x minus 3. But again, we can't just leave it in this form. We have to convert it to standard form. So we can do that by just expanding this factored form. So we get y equals 3 times x squared minus 1x minus 6. And then this is equal to y equals 3x squared minus 3x minus 18. And this is your equation for this graph. And what we did here is we used our knowledge of like how to factor quadratics and like reverse that thinking. If we have both the zeros, we just plug them in into the x plus 2, x minus 3, and then we use a third point to find a. And what if we have something like this? In this graph, we're given the x-intercept, the y-intercept, and one other point. We aren't given the vertex, we are only given 1, 0. So how do we do this? Well, first, let's write out standard form for quadratic. Y equals a x squared plus bx plus c. And so we need to find a, b, and c in order to complete this. So first, let's just plug in some of the points. Let's try the y-intercept first. 0, negative 6. So plug in 0 for x and negative 6 for y. So negative 6 is equal to a times 0 to the power of 2 plus b times 0 plus c. And this is just equal to negative 6 is equal to c. We get c very easily. So as you can see, by plugging in the y-intercept into here, we can get c very easily. So let's just replace c with negative 6. And then now let's plug in the other points. So let's try the x-intercept next, 3, 0. So that is 0 equals a times 3 squared plus b times 3 minus 6. And then we get 6 is equal to 9a plus 3b. And then here we can divide this whole thing by 3, and we get 2 is equal to 3a plus b. And then here we have a and b related to some number. Now let's plug in the next point, negative 2, 10, into this equation. So we get 10 is equal to a times negative 2 squared plus b times negative 2 minus 6. And then we have 16 is equal to 4a minus 2b. And again, we can divide this whole thing by 2. So a is equal to 2a minus b. And notice, with these two, we have a system of equations. So let's get b in terms of a. So we get b is equal to 2 minus 3a. And then we plug that back into the other one. So a is equal to 2a minus 2 minus 3a, because that's equal to b. And then we get 8 is equal to 2a minus 2 plus 3a. And then with this, we get 10 is equal to 5a. That means a equals 2. And let's plug in a equals 2 into this. So b is equal to 2 minus 3 times 2. B is just equal to 2 minus 6, which is negative 4. And look, we found C, B, and A. So let's just replace C, B, and A in the original form. So B is negative 4 and A equals 2. So y equals 2x squared minus 4x minus 6. And this is our final answer. And the work is a little messy, but basically what we did is just we plugged in all of the points into this equation and then simplified them. We got a system of equations, and we solved that system, and we got our final answer. Now let's do some practice problems. If we think you can find the equation from this graph, then pause the video and try it. But for this graph, we're given the vertex, which is negative 3, 0, and we're given the y-intercept, which is 0, negative 12. So for this one, we can use the vertex to plug it into vertex form. So y is equal to a times x minus negative 3, which is just plus 3 squared, and then plus 0. But we can get rid of plus 0. So all we need to find is a. We can use the other point to find a. So plug in negative 12 for y and 0 for x. So negative 12 is equal to a times 0 plus 3 squared. And we get negative 12 is equal to a times 3 squared. And 3 squared is 9, so negative 12 is equal to a times 9. And we get a equal to negative 12 over 9, which is equal to negative 4 over 3. And we plug in the negative 4 over 3 back into the original equation, and we get y is equal to negative 4 over 3 times x plus 3 squared. But don't forget, we must simplify this into standard form. So we expand this x plus 3 squared into y equals negative 4 over 3 times x squared plus 6x plus 9. And we multiply each term by 4 over 3. So y is equal to negative 4 over 3 x squared minus 8x minus 12. And this is our answer. If you want to, you can multiply all of this by 3 or do whatever you want to get rid of the fraction, but it's fine to just leave it like this. Now let's do another practice problem. In this one, we're given both of the zeros and we're given the y-intercept. So if you think you can find the equation from this graph, then pause the video and try it. But what we can do here is plug these zeros into the factored form for a quadratic. So y equals a times x minus 1 because 1 is a 0, and x minus 3 because 3 is a 0. And we need to find a next, so we just plug in this y-intercept into this to find a. So 3 is equal to a times 0 minus 1 times 0 minus 3. And then we get 3 equals a times negative 1 times negative 3. And 3 equals a times negative or positive 3. So a is just equal to 1. So we can just get rid of the a, we can ignore it. So we have y is equal to x minus 1 times x minus 3. But we need to expand it to convert it to standard form. So we get y equals x minus 1 times x minus 3. And this is equal to y equals x squared minus 4x plus 3. And this is our answer. So what we did, again, since we know the zeros, we can just put it into factored form and then find a using a third term, which is our y-intercept in this case. And then we just FOIL this out into standard form. So everything that I explained in this video should teach you everything that you need to know to find the equation of a quadratic function from a graph, given that you have enough points to do so. If you learned something from this video, then please consider liking and subscribing, as it helps us out a lot.